Okay, this is what we went over yesterday. We talked about our reference angles and we drew our triangles. Now we're gonna draw some, it's okay. We're gonna draw some special triangles. What are our special triangles? And that would be a 45, 45, 90. No, that's it. Those are only special ones. So we're gonna use these special triangles. Oops. To help us do the unit circle. My ring got caught in my earring. Okay. Special. Right triangles. To evaluate trig functions. Right. Yes. Okay. Do you want to start off with a 45, 45, 90 or a 30, 60, 90? Okay. That's where we're going to start. Let's start with our axis and our unit circle. Unit circle. Okay, that was actually, one side's a lot bigger than the other. Okay. Now, when I put this in my triangle, I put my triangle into my unit circle, I start at my initial, and I go to my terminal side of my triangle, right there. That is my point. And let's make a triangle from that point. Now, my reference angle here is down up front, which is 45 degrees. What's this degree right here? 90. Yep. Sorry, this red is very, very dark. So this one up above is also going to be 45 degrees. So we have a 45, 45, 90. Now, thinking all the way back to algebra, who remembers our triples? Yeah, do you remember our Pythagorean triples? Yeah? Do you? That's Pythagorean theorem. So there are some nice numbers in these to try and figure these out. So we're talking about our short side. So first, let's talk about our long side, I guess. Yo, Benj, you're gonna share with me too? Yeah, okay. What side of this triangle do we know right now? What side of this triangle do we already know, given that we're in the unit circle? Hypotenuse is 1, yes. My triple for 45, 45, 90 is S, S, S square root of 2. This is my 45, 45, 90. These are the angles that are opposite the sides. I'm eating at the same time. So our two short sides that are opposite 45 are going to be called S and S. We got to figure out what these S's are. We already know one side. We already know that the hypotenuse is 1. We got to figure out the other two S's. So we can set 1 equal to S square root of 2 using our triples. So I'll have to get S all by itself. What is the first thing I should do to get it all by itself? So I have 1 equals S square root of 2. So, because this is a triple. From way back when in geometry, this is a triple they use for 45, 45, 90. So any 45, 45, 90, the two short sides are going to be equal. And the third side is going to be that side times the square root of 2. Yeah? Okay. So to get S all by itself, what do I have to do? By what? I want... I'm going to divide something on both sides of these to get rid of the square root of 2. Yeah, square root of 2. Square root of 2. So, Ben, what does this equal? Yeah, but do we ever write a radical in the denominator? No. So what do we have to multiply it by? So it's not. Yep, square root of 2 divided by square root of 2. So a clever choice of 1. What would that equal, Benj?
1 square root of 2, or just square root of 2.
Okay. What about down below?
2.
Yep, just 2. These will multiply by the square root of 4. And the square root of 4 is 2. You got it, Yale? Yeah? Are you writing it down? Okay. We just found that these two sides are no longer s. These two sides are what? Yep, perfect. Okay. You can all tell me what this point is right here, right now. What is this coordinate point up top? Given that I went over this length, which you said was square root of 2 divided by 2, and we went up the same length of square root of 2 divided by 2. So what's my coordinate? What's my x value? What about my y value? Yep. So if I asked you guys, what was this cosine and sine of this, what would it be? Yep, square root of 2 divided by 2. This would be square root of 2 divided by 2. And then what would tangent be? Tangent of theta, which in this case is 45 degrees. So we can type in 45 degrees here. What is tangent?
Cosine over sine over cosine.
Which way is it? Which one's on top?
Square root.
Is sine or cosine on top? Okay, I heard one cosine over sine. Wenzel, what do you think it is? Okay, y'all, what do you think it is? Yep, so it's sine theta over cosine of theta. So I would have square root of 2 over 2 divided by square root of 2 over 2. What would that equal, y'all? Yeah. Yeah, 1. Because it's the same thing on top, same thing at the bottom. So equals 1. Great. Okay, let's fill this in with our unit circle. Grab your unit circle. So how much was our reference angle when we were doing that? In a 45, 45, 90. What was our reference angle? What is the angle between our terminal side and the x-axis? 45 degrees. So I'm from here to here, so I'm at 45 degrees. I will wait until you guys find your sheets. Yeah, you got it. Cool. Grab a pen. Okay, so we're all at 45 degrees? Okay, so our coordinate point we said was square root of 2 divided by 2. Square root of 2 divided by 2. Yeah, what was my tangent at that time? At this point, what's tangent? Yep, what did you say it was? Yes, which equaled what at this point? 1, perfect. Okay. I know. Do you want to go close the door? Thank you.
Big children.
Well, you can hear Mr. Holloway, can't you? No, well, gotta fill out the unit circle first. Next time. Okay. Like in a minute. Okay, so if I go another. Okay, actually, that's it. We have to close down. Okay. I'm gonna put the same triangle in a different quadrant. Which quadrant do you want to put it in, Jade? 2? Okay. So how would I draw that? Let's do a bow ties and butterflies to figure out how we're supposed to draw that. Up here, down below, as such. So, I know. That's what someone else said in the other class too. So, tell me when I should stop at quadrant 2. Yep, okay, I'm on quadrant 2. So is this my reference angle? No. Is this my reference angle? Which one is my reference angle? Up here is no, down here is 90 degrees. It's always going to be right here. Touching the x-axis right there. So this is going to be 45 degrees still. We're still in the same one. Okay, you guys can already tell me what this point is. You already know what this point is. We just have to change if things are positive or negative. Yeah? Okay. So is cosine positive or negative in this axis, this quadrant? Negative. Yep. So it's negative what is cosine? Yeah, square root of 2 divided by 2. Great. Now, sine is what? X or y? Yeah. Is sine of theta or x or y coordinate? Y. Okay, so we're over here right now. Is it positive or negative in quadrant 2? Okay. Yeah, because A, S, T, C. So sine is positive over here. So quadrant 2, it's square root of 2 divided by 2. Then what is tangent of theta in this case? Negative 1. Yep. Great. Okay, now we go back to a unit circle. You good? You good, Bench? Okay. Okay. Back to here. So we went into quadrant 2. So up above here, we had negative square root of 2 divided by 2 and square root of 2 over 2. And our tangent was what? Negative 1. I'm just going to write it up above. Okay, Benj, you got quadrant 3. What degree should I be at right now?
225.
Yep, okay. What is my coordinate here?
Negative. So it's therefore negative.
Okay, so the entire thing.
Yep.
What's the coordinate?
Negative 2 squared divided by 2.
Yep. And square root of 2 divided by 2. And what would tangent be? Positive 1, because these are both negative, and we can always remember all students take calculus. We're in this quadrant, so t is positive, so tangent is positive. Okay, scooching over. What angle should I be at now, Yale? Yeah, what angle? So I'm going to go another 45. I would go here. And if I want to go another 45 degrees, where would I be? Yeah, 315. What would my coordinate be here? Square root of 2 over 2. Mm-hmm. Perfect. And would tangent be positive or negative 1? Negative 1. Perfect. Okay. We got one of them down. We got two more to go. Okay. Let's scooch down a little bit. And we're going to do our other special triangle. What one is next? What type one? What type of triangle? What type of special triangle is next? 30, 60, 90. And let's have our reference angle for this one be 30. Okay, that's kind of close. Okay, we have, start here, go about 30 degrees, so maybe like right there. 90 degrees here, we got 30 degrees here, and we got 60 degrees up top. Okay, do we remember a triple for 30, 60, 90? Do you remember a triple for 30, 60, 90? A Pythagorean triple, like before it was s, square root of 2? No? Okay. So my short side is always going to be s. We always start with s. The hypotenuse, in this case, is going to be twice s. So this is 2s. My other leg here is going to be s square root of 3. So s square root of 3. Which side do we already know, Wenzel?
The S.
Jade. He's got to know himself. Which one is the radius? Which one represents the radius? S is this side right here. Okay. Which one starts at the center and goes to a point on the circle? Yep, 2s. So 2s equals what in this problem? Yeah. What is the radius of the unit circle? What is always, it's a unit circle. What's the radius of a unit circle?
Oh, S.
What's the radius of a unit circle?
Oh, R.
R, radius in the unit circle is always 1. So we know that the hypotenuse, 2s, is supposed to equal 1. So if I want to get 1 all by itself, what do I have to do in this equation? Yeah, divide by 2 both sides. So you know s equals 1/2. Perfect. So let's change our sides to equal what they are shown. So this side, we said was 1. This side over here is now 1/2. Now we gotta figure out this side at the bottom. What the side at the bottom would be. What would s square root of 3 equal if s is 1/2? So 1/2 times square root of 3. What would that equal? Square root of 3 divided by 2. Yep, we're just putting it all together into 1. So this side over here is square root of 3 divided by 2. So Yell, you know this already. What is this coordinate right here then? Well, yeah. Okay. This is my y, right? This is x, this is y. Y is going up vertically. So how much should I go up vertically? So vertically is like this direction. So how much should I go up? What is this length of this side right here? That's this angle. That's this angle. What's this length right here? What do we figure out s to be equal to? Yep, 1/2. Mm-hmm. Okay. So this one, 60. Yeah, that just released it. Okay, figure out what tangent of 30 degrees is here. Tangent of 30 degrees is the same as sine of 30 degrees over cosine of 30 degrees, which this is our y over our x. What's our y coordinate? 1/2. Yep. What is our x coordinate? Okay. Do you guys remember keep, change, flip? Okay, keep, change, flip this guy. Okay. So this equals, we keep our 1/2. Yeah, we're going to keep our 1/2. We change division into multiplication, and then we flip the last one. So this is my denominator. Now it becomes my numerator, and my numerator becomes my denominator. Yeah? Okay, can you simplify those? Multiply them together. 1/2 times 2 square root of 3. What's that equal? What is 1 times 2? Okay. What is 2 times square root of 2? Square root of 3. Yep. Okay. We're going to simplify this. What can we get rid of already? I'll get rid of the 2's. Yep. I have 1 square root of 3. Now, we don't like radicals in the denominator. So what should I multiply this fraction by to get rid of it? Just the square root of 3? Yep. Jade, what would that equal? Over what? 3, yeah. So the tangent here, so tangent of theta, in this case, was square root of 3 over 3. Do you have any questions before we keep going? That how we got any values? Okay. Who wants to put the triangle in a different quadrant now? Jade picked the last one. Who wants to go next? Yell, you pick. 3 or 4? 3? Okay, tell me when to stop. Which quadrant is 3? Yep. We're going down there. So let's do a bow ties and butterflies and draw my triangle down there. Boom. So this is now 30 degrees. So you guys already know what this point is going to be right here. Wenzel. We're keeping the same point as above. We're just changing what's negative and what's positive, right? Yeah. Okay. So is this negative or positive for cosine down here? Negative. Yep, negative. Negative what? Yep, okay. What about 1/2? Is it positive or negative over here? Negative 1/2. Great. So then tangent, is it positive or is it negative? Positive. Yeah, positive. Positive 3 square root of 3. Yeah. Okay, let's put it on a unit circle before we keep going. Yeah? Okay. So, my reference angle was 30 degrees. So I'm at right here. We said this was square root of 3 divided by 2 and 1/2. And tangent was what? Yep. And what was the value? Square root of what? Perfect. Okay. Now I can't really go 30 degrees here, but I can go to my other pi 6. Where's my next pi 6, Jade? Where's the next pi 6? Yep, where is the next time there's a 6 in the denominator? I'm at 30 degrees, and I have a denominator of 6. It's going to repeat again when I have a reference angle of 30 degrees, which is always when there's a 6 in the radians. Yep, 150 degrees. Okay. We said this was square root of 3 divided by 2 and 1/2, and the square root of 3 over 3. Which one is positive and which one is negative? Anybody? The x? Yeah, that one's negative. Perfect. Now, what about tangent? Is it positive or negative? Negative. Yep, so this is also negative. Oh. Benj, what's my next degree I have to go to? Where else do you see a reference angle? So this is 30. So we're kind of doing bow ties and butterflies. This one was 30. So this one has to be 30. And this one has to be 30. So wherever it touches those lines. So where's my next degree? 210. Yep. Okay. What is positive and what is negative here?
The tangent is positive.
Okay, so positive 3 square root of 3. What is my cosine?
Negative. Negative. Both of them are negative.
Yep, what is it? What's the fraction?
Negative 3 over 2.
Square root of 3 over 2. And then I have a negative 1/2. Good job. Okay, I'll do the last one. I should be at 330 degrees. I'm going to have a positive cosine of 3 square root of 3 divided by 2. And then my sine is going to be negative because I'm going down the y-axis. So negative 1/2. That makes my tangent negative. So negative square root of 3 divided by 3. Guys, we're almost done completing the unit circle. We're just almost done. We got one more to do. Guess what? It's the same thing as what we just did, except we're flipping it over. So we're still going to keep a 30, 60, 90. Except our reference angle is going to change. What do you think it's going to change to?
60.
Yep, changing it to 60. So now I started here. I'm going to go up 60 degrees. So about like right there. So I'm down here and I'm over here. Okay, you guys already know all sides of this triangle already. So this is 60 degrees and this is 30 degrees. Boom. Okay. Wenzel, give me one side of this triangle. Give me any side of this triangle. You already know all three sides. I know you do. But tell me one of them. One is one of them. Which one is that? So this is S. This is 2S. And this is S square root of 3. So this length is our radius in my unit circle. So what is the radius of the unit circle? Yeah, so 2S equals what? You already know this length. What is the radius of the unit circle always? Look on your unit circle. Oh. The unit circle, what is the radius of my unit circle? 1. Perfect. 1. Yep. So 1. Perfect. We know that this length over here is going to be 1. Ben? Benj. I don't know why I just call you Ben. What's the other two sides? Other two sides. You already know what S is because we already calculated before. What was S in the other one? 1/2. Perfect. And guess what? You know the last one too. What's the last one? What's this length over here? Yeah. So Jade, what's my point over here? What's my point? Negative?
Square root of 3 over.
Yeah, perfect. It's the same thing as the last one, but we just switched the coordinates. Okay? But we still got to figure out what tangent is. So tangent of the 60 degrees is sine over cosine. So Wenzel, what goes on top? What goes on top if sine of 60 degrees is supposed to be on top? So what is sine over here?
1.
Mm.
Oh.
Sine is x or is it y? Y. So what's sine? Great. And this is 1/2 down below. So we gotta do the same thing. Keep change flip. Yeah, what is this simplified to? Mm. We can't multiply it inside to the radical. What happens to these 2's? Okay, let's multiply. So we have 2 square root of 3 divided by 2. Okay, what is it? Yeah, square root of 3. That's it. These 2's cancel out, and we're just with square root of 3. So we just found tangent here as well. So tangent of theta equals square root of 3. Yeah. Okay, do you have any questions before we put them on the unicycle? No? Okay, do you want to reflect it, or do you think we got it? Okay. Okay. Benj, where am I at? What degree? Okay, what is my coordinate at 60 degrees?
It's 1/2 positive. And then square 3 over 2 positive.
Great, and what's tangent here?
2 positive
Perfect. Okay, I'm going down the line. Yell, what degree should I be at next? Wait, what degree am I at? 120, perfect. So you said negative 1/2? I concur. Yep. What's my sine value? Yep. So sine is y. Great. Perfect. Okay, Wenzel, you're next. What degree should I be at now?
Oh.
What degree? You gotta tell me when I'm... Okay, I went here. I went 60 degrees. Then I went another 60 degrees. Then I went another 60 degrees. Then I went to another 60 degrees. Where am I at? 240, yep. Okay, what is the coordinate at 240? Mm-hmm. Yep. Okay, and what's tangent? Square root of 3. Yeah. Okay, what about over here? Jade, you next. 300? Okay. Yep. And what's tangent? Negative square root of 3. Perfect. Okay, we're so done. Almost. We have one more thing. We did not do tangent at 0, 90, 180, and 270. Okay. over here, we gotta figure out what tangent is. So I gotta put y over x to get tangent. What is my y value? What is my x value? Okay, what does that equal? 0. So equals 0. Yep. Okay, what about up above? What would tangent be here? Yes, I can never divide by 0. So this is undefined. Okay. Over here, what would tangent be? Yep, tangent of theta equals 0. Anyone want me to walk you through why it's 0? Yeah. Okay. Tangent of theta is always what ratio? What's on top and what's on bottom? Always y over x. Yep. And what is 0 divided by -1? 0. Yep. So it's 0. Okay, down below, tangent of theta would be -1 over 0. Anything divided by 0 is what, Wenzel? Try on calculator. I'll get you a calculator so you don't have to do that. Divide something by 0. Well, -1. Do -1 divided by 0. What would it be? Has that been there the whole time and no one told me?
Yeah.
Nice.
I thought it was part of it.
No.
Oh, I noticed it wasn't going to, so I was like,
Wenzel, what did it equal?
Divide by 0.
Error. Yep, so it's undefined. I can never divide by 0. Guys, you just completed the unit circle. You should be so happy and proud of yourself.
so told me we're gonna get an assignment with the answer by yourself.
It's today Wednesday. So tomorrow,
It's test.
No. Quadratic.
so tomorrow, because I don't want you to spend 3 days without looking at this guy, we're going to do a quiz. And you have to write down everything on the unit circle. Yep.
Oh, we're gonna memorize this all.
Yep.
Okay.
I'm literally going to give you this exact document, but blank, exactly how we started it.
Okay.
And you don't have to give me tangent. Tangent will be maybe an extra credit point. Yeah? Okay. So I will need radians all around. So that's what's in green. I need degrees in orange all around. And I need blue, and I need my coordinates. I do. Wait. Okay. Do you want me to teach you a trick? Okay. Can you count to 3?
No.
Okay, ready? Let's do it. Ready? 1.
1, 2, 4, 3.
Okay, that's all you have to do. That's literally all you have to do to get the points. Okay? So we know the whole all students take calculus, right? Okay, so you know when the positive and negative. Okay, let's look at these points right here. Okay. What is every single denominator in every single fraction? 2. Perfect. Okay. Now, if you look here, if this would focus, what's on top here?
1,
What's on top here?
2,
What's on top here? Okay, let's start. 1, 2, 3. Okay? And what's on top here? What's on top here? What's on top here? Okay, so 1, 2, 3. And what's in the denominators? 2, 2,
Easy.
2, 2, 2, 2. Okay, now which ones have square roots?
3.
Yep, all 3 is in all of numerators of 2. Boom. Okay, I know it's kind of messy. Yes. Okay, boom, that's all you have to do. And then remember which one's positive and negative? And we know that because of all students take calculus.
All
I also, that what goes in my head every single time. Thanks, Cash. Yes, okay. How we feel? Yeah? Okay.
not the
Okay, but then you also have to remember the 90 degrees, the 360 degrees. Okay, and then radians. Do you want to know a trick for radians? Okay. Okay. You see pi 6? Okay. You see this line? If I connect this line, it goes to pi 6. And it makes an x. Those are all the radians ending in pi 6. Okay, so if I go to pi fourths, if I make a line down, I'm at pi fourths underneath. Yeah. Okay, guys, if you just remember this quadrant, it's the same thing, but it's just moved around. Yeah. And you just have to remember you're adding like pi fourths, and another pi fourths. So it's just adding. Guys, the most difficult thing is the radians. The points should not be the difficult part. Okay. You guys got it? You're gonna do so well tomorrow. Okay. Oh, okay, ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each one, I don't know. I haven't made it yet. Well, it's gonna be out of like.
Is it a quiz?
It's a quiz. No, it's a quiz. I can't make it a test. It's too early. The whole thing. Every single blank. It's every single blank.
Not the tangent.
Not tangent. Yeah.
Extra credit?
If you get something wrong, it will boost up your. Yeah. Well, you don't have to give me tangent. What? This? You have it right there. Guys, if you look up the word unit circle, you're gonna see 1,000 images of it. No, it's always the same. Always the same. Yep.
Rain, rain.
We're done, right?
This is the perfect.
Yeah, okay, wait. I want to do. Yeah, Wenzel, you can go to the bathroom. We'll do one more thing for 7 minutes, and then maybe we'll go outside.
Yay!
Yeah? Okay.
I don't have my jacket.
Okay, Wenzel is leaving us. But guess what? We're gonna learn a Pythagorean identity, which is gonna be your like first trig identity. But if I say Pythagorean, what comes into mind? Yep. So we're gonna use that to help us. Pythagorean. Pythagorean. Yep. Is this an A?
Wasn't the guy that created the name Pythagoras?
It's just some old man's name. Yep. Just a Greek man's name who actually didn't actually invent Pythagorean's theorem.
It was his assistant, right?
Like people knew it before that. They just didn't they didn't call it something. Because they like had the equation, but they didn't have like a name for it. And like a whole different types, like all different societies had it. Just no one like put it in a book. And this guy put it in a book and like actually gave it a name and spread out the knowledge. So he got to name it. Okay, we're not doing Pythagorean theorem. We're doing Pythagorean identity.
Is that something we had done before?
You know Pythagorean theorem? No, you have not. Okay, identity. That's very messed up. Okay, Pythagorean theorem. The theorem states what?
A squared plus B squared will always equal to C squared.
Yep, always if it's a what type of triangle? If it's a 90-degree triangle. Yep. Okay, let's draw a quadrant. Boom. As such. Now let's draw our triangle. And I'm going to draw my triangle in quadrant 2. Am I writing it?
Yes.
If I'm writing it, you should write it. Okay, this is where we're at. And we are in our unit circle as well. Ooh. I'm just going to draw that because I'm going to be done. I'm only going to draw a quadrant 2. Okay, what side of this triangle do we already know? hypotenuse, which is 1, because unit circle radius is always 1. This is 90 degrees. That's all we know right now. Okay. Sine. Is that a x or a y? Y. Yep. So this right here is equivalent to whatever sine theta is. This length right here. This length from here to here is equivalent to cosine of theta.
What part is the sine?
Sine is x. So sine theta, yes, you're so right. I'm so glad you said that. Is always y. Cosine of theta is always x. Okay. So I have a squared plus b squared equals c squared. Let's plug in these values. What is a? It could be either one. Yep, so let's say it's sine of theta. Okay, is sine theta positive or negative here? Positive.
Negative. Positive.
And cosine is what? Negative. Perfect. So sine squared plus our other side, so negative cosine of theta squared equals what? 1. And I'm going to say it's squared for now, but it's just going to equal 1. Okay. Yeah?
Can we back then like it just like what's like on your like board with like there's like a lot of things happen and then it was gonna shatter because there's a lot of things
Wait. Oh, I'll put calc. Wait,
If we
where is it?
gonna act like bro this is a lot.
For David.
Yeah.
Wait, it's not here.
Which one is pre-count? Chicken or egg?
This?
Like a lot of things and then yeah, that one.
How long does it take this dude to go to the bathroom? That's the question.
No. It was
No, it's okay. Wait, sit back down. Sit back down.
guys, okay, just like teach us like some of it so we can know like
This?
yeah.
Okay, so do you guys know what matrices are? Guys, this is so much fun. Matrices. So matrices are something, oops. Oh, I need to be in this level. So if I had an equation like 2x plus y equals 5, and I have, I don't know, 5x plus 4 equals y, oh, y equals 2. You would use like substitution or elimination to solve this, right? Okay, so instead of that, we would use a matrix, something that looks like this. It would just take the coefficients, so 2 and the 1, take the 5 and the 4. Wenzel, you kind of missed a little bit.
You need to copy this.
Yeah. Okay, I know you kind of missed it. You got to watch the video. Okay. Wenzel, this is pre-calc. No, this is actually calculus. No, it is pre-calc. Yeah. It was just a joke.
Bro.
You didn't even get it. Look, this is a law on the screen. This is a different class. This is a lot. No. Okay. Back to our class. That's fine. Not at all. I know, I gotta find it. Okay, back to, this is what you need to copy down. Okay, we're doing a Pythagorean identity. So we looked at a triangle, x and y inside of it. Oh, for the people in the video, that was, I don't know. Sorry, people in the video. Okay, sine of theta squared. We're just gonna square it. Now, we don't write it like, oops. Don't write this down, this part. We don't write it like this. Okay? It looks like we're squaring theta, right? We don't do that. We're squaring all of it. So we don't write it like that. We write it like this. We do sine squared theta as such. Okay? But when you type in the calculator, you probably have to do sine of whatever this is, and then you have to square it like that. Yeah. Okay? Okay, now I gotta do the same thing to cosine. Now if I square a negative, what happens to it? Yeah, so I'm multiplying negative cosine of theta to negative cosine of theta. So it becomes positive cosine squared of theta. And what is 1 squared, Wenzel? Yeah, 1. Yep, that's it. 1. That's it. These are always going to be positive. This is what we all have to remember. This is the important bit. This is the Pythagorean identity. Sine squared of theta plus cosine squared of theta equals 1. This will work for any angle you got. What? As long as we're in the unit circle. As long as our radius is 1 and we're in the unit circle, any point on the unit circle, if you sine squared plus cosine squared of theta will equal 1. Yep. Yep. Wenzel, you copy this, and when you're done, we will go outside.